Hello students, welcome back to the session. In the last session we are talking as how to represent the hexadecimal digits in binary format. That is 1 is represented as 0 is represented 0 0 0 0 1 0 0 0 1 0 0 1 0 0 0 1 1 0 1 0 0 0 1 0 1 0 1 1 0 and 0 1 1 1. So this becomes your 0 1 2 3 4 5, 6 and 7. Now if you want to represent 8 becomes 1 0 0 0. Keep on adding 1 in the same way, that becomes 1 0 0 1 1 0 1 0 1 0 1 1 1 1 0 0 1 1 0 1 and this is your 9. 10 is represented as A, B, C, this is your D, and E is 1 1 1 0 and then F is 1 1 1 1. Okay, so this is how you are going to represent the hexadecimal digits in binary format. Now how do you go for your conversion? It is in the same manner as your octal to binary conversion, but the only difference is instead of 3 bits you are going to take 4 bits. That is, for example, you have the binary number 10110001. Now if you have to convert this into hexadecimal, that is to the power base 16. Here 1, I am writing the same thing, repeating again 001. Right. Now from the right hand side take 4 bits. Okay. And this is your next 3 bits. But as you have only 3 bits over here, add 1 0 to this. So now according to this table that you have done here, what is 0101? 0101 is your 5. Right, so this is your 5. And what is 1001? 1001 makes up your 9. Right, so 9. So the answer is 59 to the base of 16. Okay. In the same way, if you have a fractional format, that is 0.110101. Okay, so what does this make? So again, if you go for the if you have a fractional part, the division of bits is made from the left hand side, that is from this side, and then 0. What is 1101? 1101 is your D, and this is your D. What is 0111? 0111 makes up your 7. Right? So 7. So the answer is 0.D7 to the base 16. So this is how you are going to represent a hexadecimal or convert a hexadecimal number into a binary number. Now the next, in the same way, we are going for the conversion of hexadecimal to binary. Hexadecimal to binary conversion. So how do you make this? Now for example, you have CEBA. This is present in your base 16, that is in your hexadecimal. So how do you convert this into base 2? Now it's very simple. What is C represented as? C is represented as 1100. So write that 1100. What is E represented as? Go for the table 1110. So 1110. What is your B? B is represented as 1011. So 1011. What is your A? A is represented as 1010. So 1010. This is here to the base 2. Understood? So this is how you are going to convert the number from one form into the other form, or one number system to other number system. And again, you have one more method, that is your one more conversion, that is your octal to hexadecimal number system, which we had not done, right? Octal to hexadecimal number system. So using this binary system, you can usually convert the octal numbers into hexadecimal numbers also, and the same vice versa also. So what you are going to do here is, first you have an octal digit, write the binary equivalent of this digit, convert it into binary, and then this again regroup this binary into 4 bits to make it into a hexadecimal conversion. So you are going, if you have only 3 digits to the extreme ends, add a 0 to the right side and then convert. Now for example, you have the number 274 which is in base 8. You have to convert it into base 16. So what is the binary equivalent of 2? 2 means 0, 1, 0. What is the binary equivalent of 7? 7 is 111. 4 is 100. So what is your 274 which is in octal system? If you convert it into binary, what is the answer that you get? You get 0, 1, 0, 111, 100. So 0, 1, 0, 111, 100. As we said, go from the left hand side, okay, and group it into 4 bits because we need the hexadecimal. Hexadecimal means 2 to the power of 4, that is 16. So you have to convert it into 4 bits. So 4 bits, this is your 4 bits, this is your 4 bits, and you have just 1 0. So add 3 zeros, that becomes your 0. Okay, or sorry, just a minute. 0, 1, 0, 111, 111, 00. Okay, sorry, we are supposed to regroup it into 4 bits from the right side, right? So this is your 4, this is your 4, and this is your 0. So 0, even if you add 2 zeros to this side also, it remains 0 only. So what is your 1011? 1011 is your B. 1011 is your B. And what is your 1100? 1100 is your C. So what is the answer? 278, which is in base 8. If you are going to convert it into hexadecimal number system, the answer is B and C. BC to the base 16. That is the conversion. How do you convert? Now, in the same manner, how do you convert a hexadecimal number into an octal number? Hexadecimal number to an octal number. How do you convert this? Well, let's take it again in the same way. You write the binary equivalent for each hexadecimal digit and then regroup them into 3 bits from the right side and add zeros on the left side when necessary and convert each group into octal equivalent. Now, for example, you have fade, F-A-D-E, fade. Okay, what is the value of F? F means 15. 15 means 4 ones. And A, what is your A? A means 10, that is 1010. And D, D means 13, that is your 1101. And E, E means 14. 14 means 1110. Right? Put everything together, that is 1111, 1010, 1101, and 1110. Starting from the right side, you go on dividing it into 3 bits because we are supposed to convert it into octal. Octal means 3. So this is your 3 and this is your 3 and this is your 3 bits. This is your 3 bits and you have 1 over here, add 2 zeros. Okay, so what is 001? 001 means 1. 111 means 7. 101 means it is 5. 011 is 3. Again 011 is 3. 110 is 6. So this number, that is fade, which is in hexadecimal, when you convert it into octal, you get it as 175336 in the octal system. So this is how you are going to represent or convert a hexadecimal number system into a octal and octal to hexadecimal number system. Okay, hope you understood this conversion. If you have got any doubts, you can ask me when you come for the live class and we'll clear it once again. So let us go for the next section of this chapter, that is representation of signed integers. The representation of signed integers. Now, as we know, digital computers can handle both the positive integers and negative integers, right? But you need a method where you can represent the sign of the number. Positive is represented as plus and negative as minus. But when you are using a digital system, you cannot write this plus and minus symbols. So what you're going to do is you add one leftmost bit, extra bit, called as the sign bit. So this is added on the left hand side. So as positive sign will have a sign bit of 0. If you want to represent a positive sign, you give a sign bit of 0. And if you want to represent a negative sign, you give a sign bit of 1. So it is also known as your fixed point representation. And this negative sign, you can represent it in different ways. One of the ways is your sign and magnitude representation. Sign and magnitude representation. The other method is ones complement representation, and the next is your twos complement representation. So let us go for your sign and magnitude representation. Sign and magnitude representation. So if an integer that contains a sign bit followed by magnitude bits, then they are called as sign magnitude integers. That is the most significant bit, that is your MSB, most significant bit will always be the sign bit, and the remaining bits always stand for the magnitude. Now for example, in a computer, if you have 8 bits, then if you want to represent a digit 83 plus 83 and in the same way minus 83, how are you going to represent it in an 8 bit? For example, you convert this into base 2, that is it, because it is always represented in a binary format. 2 4s are 2 1s are 2, 1 carry, 2 2s are 4, 2 0, 1 carry, 2 10s are 20, 0, 2 5s are 10, 0, 2 2s are 4, 1, 2, 1s are 2, 0, right? So 1 0 1 0 0 1 1. When we are saying 8 bits, 1 2 3 4 5 6 7 8, right? So how many digits do you have? 1 2 3 4 5 6 7. So 1 0 1 0 0 1 and 1. So you are going to add a sign bit over here. Okay, this is your sign bit. If you are adding a 0 here, then it means it is a positive number, plus 83. In the same way, one zero one zero zero 1 1. Okay, if you add a 1 over here, this is your sign bit, and this represents a negative number. As we said over here, if you are using 0 positive, 1 means negative. If you are adding a 0, it is positive. If you are adding a 1, it is a negative number. Okay, so this is how you are going to use the sign and the magnitude. This is your sign and this is your magnitude. Okay, this is your magnitude. This is one way of representation of sign integers. That is a positive number or a negative number. And the next method is your ones complement. Ones complement representation. This is one of the easiest method. This is a simple method of representing a negative binary number. So what you are going to do here is the negative binary number. You are going to get a negative binary number by subtracting the value of each bit in the word from 1. This means that you are going to change the value of each bit from 0 to 1. 0 is always converted to 1 and 1 is converted into 0. Do not worry your head. Only the conversion what you are going to do here is, if you have a 0, change it to 1. If you have a 1, change it to 0. So for example, the binary, you have a binary number 101000. So this number, if you want to convert it, make it into a ones complement, means what you are going to do, so convert this 1 into 0. 0 becomes 1. 1 becomes 0. 0 is 1. 0 is 1 and 0 is 1. So this is your ones complement. This is the answer. Okay, so ones complement of a number is obtained by changing all the ones into zeros and all the zeros into ones. This is your ones complement representation. Understand this concept because you have problems next. So next is your twos complement representation. In twos complement representation, again you follow the same method as in your ones complement. Convert all the zeros to ones and ones to zeros. That becomes your ones complement. And add 1, a digit 1 to your LSB. That makes your twos complement. So twos complement of a binary number is equal to ones complement plus 1. Okay, so let us go have an example. Example is 101000. Right, the same example as we had taken earlier. What is the ones complement of this? 0 1 0 1 1 1. This is your ones complement. Right, now add 1 to the LSB. This is your LSB, least significant bit. Add 1. So 1, follow the method of binary addition. That is 1 plus 1 is 0 with a carry of 1. 1 plus 1 is 0 with a carry of 1. 1 plus 1 is 0 with a carry of 1. 1 plus 0 is 1 and again 1. And this 0 is as it is. So this is the twos complement. Okay, hope you have understood, because we have solving in we have problems which you are supposed to solve further. Understand this concept. If you have got any doubts, in the next session of the online class we will do this. Okay, so next we are going to go for the binary arithmetic. Binary arithmetic. So what is this binary arithmetic? Arithmetic means it involves addition, subtraction, multiplication and division operations. These are the fundamentals for all the digital computers. So in that, binary addition is one of the most important operation. The reason is that using this binary operation, we use it to perform all the other operations, even your multiplication, subtraction and division also. All the other arithmetic operations are performed with the help of the binary addition itself. So let us go for the binary addition now. We have already done this in the last class because we needed it there. So we'll go again. Once again, we'll repeat this process. You have some basic rules that you are supposed to follow in your binary addition. So what is that? If you know, you have the terms of product, quotient, multiplicand, multiplier, division, divisor and all this. The same way you have in your addition also. That is your addend 1, addend 2 and sum and carry. Okay, we are basically now in the beginning we are just going to go for the 4 options. That is the variable. If first one is 0, the second one will be 0. Addition is always done with first with the only 2 variables. So 0 and 0, 0 and 1, 1 and 0, 1 and 1. All the possible operations. When you have just 2 numbers, what are the possibilities that you can have? It can either be 0, or it can be 1. So again this 2 second variable can be 0, 1. So you are mixing up the variables and checking out all the possibility. So if you have two numbers which are both 0, 0 plus 0 will be 0. So there is no carry. 0 plus 1 is 1. There is no carry. 1 plus 0 is 1. There is no carry. 1 plus 1 is 0 with 1 carry. Remember, 1 plus 1 means 0 with 1 carry. This is how you are going to do the addition, binary addition. You are going to add, we will add only 2 bits. And if a carry is generated, it will be carried over to the next bit. Okay, that's even in your 3-bit addition also you are going to follow the same method. Okay, now let us go for an example. Add 75 and 18 in binary. We are saying binary format. We know 75 plus 18 means 93 is the answer. No, but we are not following this method. Okay, we have to use the binary method. You cannot do using this method. So convert this 75 into binary first. 2 3s are 6, 1 carry, 2 7s are 14, 1. 2 1s are 2, 2 8s are 16, 1. 2 9s are 18, 0. 2 4s are 8, 1. 2 2s are 4, 0. 2 1s are 2, 0. So 75 is represented as 1 0 0 1 0 1 1. Okay, in the same way go for your 18 also. 2 9s are 18, no carry. 2 4s are 8, 1 carry. 2 2s are 4, no carry. 2 1s are 2, no carry. So 18 is represented as 1 0 0 1 0 in your what? Binary format. Now you are going to add this. So when we are adding, we are going to add 75 and 18, right? What is your 75? 75. 75 means 1 0 0 1 0 1 1, and 8 is your you have 3 4 5 6 7 bits over here. 1 2 3 4 5 bits over here. So 5 means 1 0 0 1 0. You have to write like this. Okay, now 1 plus 0. 1 plus 0 is 1. 1 plus 1 is 0 with a carry of 1. 1 plus 0 is 1. 1 plus 0 is 1. 1 plus 0, 1. 0 plus 1 is 1. This 0 and this 1. You write it as it is. This is how you do your binary addition. Okay, so this is about your binary addition. Hope you understand the concept. I'm not going to unnecessarily give examples for this because as it is an offline, if you have got any doubts, you can ask me in the online class and we can continue in the next class. Okay, so now in the same way, we have the binary subtraction also. So what is this binary subtraction? It's nothing but addition of negative binary numbers. Okay, if you want to subtract 8 minus 5, you are going to do it as 8 plus minus 5. You are adding. So what are the rules over here is, you have a minuend, you have a subtrahend, and you have the difference, and you have borrow. You are used to borrow, right? So if you have 74 minus 9 means you are borrowing 1 from this, and this becomes 7, this becomes 14 minus 9, right? In the same way you are using a borrow here. Okay, so 0 0 0 1 1 0 and 1 and 1. Okay, so 0 and 0 is 0. There is no carry. 0 minus 1 is 1 with a borrow of 1. 1 minus 0 is 1 with a no borrow. 1 minus 1 is 0. No borrow. Only if you are subtracting a bigger number from a bigger number from a smaller number, you are borrowing, right? In the same way, here also, you are subtracting a bigger number from a smaller number, then you have a borrow of 1. You have to understand this. Only if you are subtracting a bigger number from a smaller number, you have a borrow. So let us just have an example here. Add or subtract 75 and minus 25. As we said, we are going to do the subtraction using the method of addition. 75, as we already know, 1001011. 25 also you are going to represent. So what is your 25? 2 1s are 2 2s are 1 carry, 2 6 are 12, 0 2 3s are 6, 0 2 1s are 2 1, right? 11001, right? 11001. So how are you going to do the subtraction now? For the subtraction now, you have, as we said, 70 means 1 0 0 1 0 1 1 and 1 1 0 0 1. So 1 minus 1, 0, no borrow. 1 minus 0 is 1, no borrow. 0 minus 0 is 0. 1 minus 0 is again 0. Here this is, you have to subtract a bigger number from a smaller number. So you have to borrow from here. If you have to borrow from here, it is also a 0. So go for the next highest number. This is your next highest. So you are going to borrow from here to here and then from here to here. So this is your, what does this become now? 1 0. 1 0 means 2. Minus 1 is 0 minus 1. Again, as we said, 1, which was a borrow. And when we have borrowed here, again this was also, you had your 2. 2 means 1 has already gone over here. So what does this mean? Again 1. So this is the difference that you have. This is the way we are going to use the binary addition and binary subtraction. I know that there will be certain confusions over here. So let us go, when we start the online class, we'll have once again repetition of your binary addition and binary subtraction. But for now, let us end this session and just understand, try to solve till you come for the next online class. Thank you.